I'm gonna just talk to you about what we have, like how do we apply machine learning, and something about my experience while working in finance and applying machine learning. So what is machine learning? Machine learning is the science of using statistics to create models which draw insight and make a prediction. These models usually learn from experience or from historical data and record, and these data are usually the experience for us. And since in financial institutes we have a lot of these data, so we have a big opportunity and a big chance to use machine learning. And I'm gonna first talk about where is machine learning in financial institute and why it's hard sometimes to apply machine learning in financial institute. First of all, machine learning research and development is expensive. So sometimes you have to really have a big budget for this, for the research and the development for these tools, and to stay up to date, because this science is moving so quickly and so on. The second thing that makes it difficult or slower to have machine learning in financial institute is the user's trust. So we noticed that the users in machine learning don't trust it. And the reason for that we lack this big trust is there are a lot of people who apply. We have these machine learning tools available everywhere, and it's easy to use them. So if I ask someone, can you use a convolutional neural network, which is it's not a very straightforward algorithm, but the use of this algorithm, it's very easy. You just input the data, you can pass the data to this classifier and get the output. So using it, having it available and using it becoming so easy, anyone can use it without even thinking about the whole cycle of machine learning. And this many times causes problems with the output or the results, in which user cannot trust these tools and they don't have this confidence. So in financial institute, they need to have enough successful story to trust this new technology or new thing. And as far as we have these successful stories, we can start growing with machine learning. And to have this successful story, again, we need expertise. We need data scientists. We need machine learning specialists. We need machine learning engineers, those people who know exactly what are these algorithms, how to use these algorithms, and then apply, pass the data to this algorithm. And I'm going to talk about this shortly. Now, why do we need machine learning? Can't we apply traditional programming and we can get the results? Whenever you can apply rules or traditional programming to automate anything, you should do this. But when there is a cognitive knowledge needed, there is a human thinking needed to make this decision. There is no rule, but the human think. To make decision, in this case, we need to apply machine learning. And the advantage of this, we reduce head count, sometimes people think, okay, headcount reduction is not so good because you will lay off people. And we don't lay off people. These people will be working on more interesting projects, because these projects, most of the machine learning projects that the machine takes over are really tedious process that is repeated all the time, and users feel tired doing it, and usually they work for a short time and then they could move to another job. Like, for example, in banks, there are a lot of documents that come to the bank. You have to read these documents and extract some information from these documents and pass them to a system. This is a very tedious process, and it's not easy for someone to keep doing this job years and years and years. So that's why for these processes, better for the machine to take. Even the call centers, it's a tedious process. If you see people who are working there, they work for a short time and then they move to another job. So here it helps them to immediately, like they can move to the other job and the machine can take over. In addition to the cost reduction followed by the head time. And one more thing, it makes things faster. So we have real-time processes instead of waiting for the human to take and do the job and then finish it and wait for the whole queue to finish. No, the machine can process them in real time, and this saves a lot of time in addition to the cost. Anyway, time is money, so this is how we can do this saving. Now I'm gonna go so quickly through the applications that we use for machine learning. We have in banks, we have predictive analysis, similar to market and financial monitoring. You want to predict the market, similar to how we predict the weather. We want to know what is the market now. There are a lot of anomaly detection. There are events that are not normal, anomaly, and you need to detect it to detect that there is something wrong happening. So these are very important in banks, and usually it's difficult, very difficult for human to do this anomaly detection, fraud detection as well, chatbots, which is mainly answer user question like call center kind of, and finally document processing and entity extraction. And this is a very important field because you find a lot of documents coming to all banks, taxes, tax forms, audit forms, and many other forms that we find them, letter of authorization, and many others that we find them in all banks. Now I'm gonna go to the interesting part. I'm not sure why I don't have the cycle here. I don't know. Okay, I'll do it this way. Oh, it's not there. Sorry for this technical problem. I'm just gonna open it again. Maybe it will show. I had the machine learning cycle here, but anyway, if we cannot see it, I will go just to the next slide and we can continue over there. I will explain it within this slide. So there is a machine learning cycle that sorry for this. So there is a machine learning cycle. I don't know why it's not showing here, but I will explain it within this slide. So machine learning, when we want to do it in the bank, we have to go through different processes. And these are different steps as well. And these steps include first that you have to go and sit with the users and make sure that your system that you are working on it is a machine learning system. So they tell you, we want you to automate this system. You want to make it a machine learning system. So in this case, you have to make sure that this system you are trying to automate is cognitive. You cannot apply rules, because usually with machine learning we have an error. So if you can apply a rule, you won't have an error, and it's better to apply rules. But if it is a cognitive problem, like extracting information from document, and this information you extract them based on the context, so here there is a cognitive knowledge. For example, you have a system that approve or reject things. There are no straightforward rules to know this. In this case, this is a machine learning system, because the machine will learn how the people think to decide, do they have to approve this or reject it? And many other, if you want to predict failure and so on, the call center, you need a human to think and answer. So in this case, you have to sit with the user and make sure that this is a machine learning problem. After making sure that this is a machine learning problem, the next step is to sit with the user, understand the problem, understand what they do, what are the processes, how do they think to solve the problem. Once we are familiar with the problem, we understand it, we evaluate, yes, this is a good use case, we start and we understand everything about it, we start with the POC. The first part in the POC is to source your data. And when we are sourcing our data, here, this is where data scientists are important and data engineers. Because once you learn what the users do, sometimes they will give you a database and tell you, yeah, you can source the data from this database, but you found that the data you need are missing in this database. So you have to look at the map or the data in the firm to see where are these missing points, so I need to source them. And also you need to create the pipeline for this data so you can take it. And in this case, we need a data engineer to help us to source this data. Sometimes it's big data. It's not straightforward. It's not, you cannot take it the normal way you take it from any databases. So the data engineer is needed here, and the data scientist who will decide what are the missing data points and from where we need to bring them, and then they source the data. Now I have my data and I finished my data engineering. After having the data, I cannot pass the data to the classifier. I have to understand it, and I have to see what is the feature engineering that I have to apply to this data to make it easy for the machine or for the classifier to do the job. For example, if I have a classification problem and I want to classify into two classes, how can I make these data separable? So I need to work on the feature engineering. Sometimes the data you have are completely different than the features that you pass to the classifier. Most of the time, it's like 50% of what you pass to the classifier, you don't see it in your data source. It's transformation you do. One of the transformation, for example, you find that people are comparing these two texts in their brain while they are doing this process. In this case, we have to do, for example, edit distance. Sometimes you need to apply more than one edit distance function. Sometimes you need to see which is better. Is it the cosine or the gradient distance? Which one can generate best results? Or I have to combine both. So this is for the data. And many other things. Sometimes you have to merge fields to each other so they become useful and meaningful. Sometimes you have to separate a field into two fields, and so on. So this data science is the thing that makes it easy for the classifier to do the job. And this is the difference. As I mentioned, these tools are dangerous. Yes, they are dangerous, because if I pass the data as it is, and sometimes we pass data because they give us the data, they say, these are our data. And from this data, we have to do the divide into training, validation, and testing. But when we do this, we have to understand that there are some fields we cannot have them until we make the decision. so that they shouldn't be passed to the classifier. So, for example, one of the fields can be the user comment after deciding to approve or reject a transaction. The user comment comes after the decision. But when I look at the data, I have it already. If I don't understand my data, I pass the comment. That comment is a clear signal for approving or rejecting. I will do the system. It will give me extremely high classification accuracy or precision. The performance will be great. And then when I go live, I don't have the comment. The system will completely fail. So this is a small example how understanding this data and engineering it properly will change everything. So always these comments have to be wiped out of the data. I don't need them. So that's how do we engineer our data. And sometimes we need to we need to do other than data transformation, like we can have a lot of categorical data. What do I do with the categorical data? Are they ordinal or they non-ordinal? This makes everything different. If they are ordinal, like the days of the week, it's a completely different thing. I can replace them with number because the order is there. But if they are non-ordinal, like the states, we have 52 states, then it's a different story over there. Or do they have high cardinality or low cardinality? And each of these make the data engineering or the feature engineering completely different. Also, once I have my features ready, based on the data I have, I need to choose my classifier. So if I have all numeric data, there are certain classifiers that work perfectly with numeric data. But if I have categorical data, there are different classifiers that work better with, like, neural network. We know neural networks are good, but when do I have to use them? Support vector machines. When do I use support vector machines? Support vector machines work very well with numeric data. Well, deep learning, do I need to use it or I don't need to use it? Do I have the amount of data that justifies using the deep learning? Because now it's a trend, deep learning, but you cannot use it everywhere. It's not needed everywhere. We always try to go for the sample algorithm that works well because we can control it more. So we need to understand what algorithm we need. And in this case, to decide what algorithm works well with your data, you have to understand how these algorithms work. And here where we need a machine learning specialist to come and help us to know, well, distributed random forest work well, or maybe the XGBoost. What is the difference between when do I use XGBoost and when do I use distributed random forest? They are both decision tree based, but when do I use each? So here comes the data engineer. And then we try the data with the classifier. Now, after this, I'm not done, even if the classifier generated good results. Then come the machine learning design. And usually the machine learning design is based on what the users want. What do they care about? And what's involved in their process? Is this a risky process? Making an error, what does it mean? Making an error means that I have to, does it cause reputational risk to the company? Or it's fine to make an error because a user will confirm my decision. So, or it's fine to make an error because I'm gonna go to another level where the user is gonna see it. So I have to look, do I care more about risk or do I care more about performance? And here we start the evaluation. We draw our precision recall curve and we wanna see where do we cut? Do we cut in the area that the risk is minimum, or we cut on the area that we generate more, we perform way better, because there are a lot of things that play a role here. So in this case, the machine learning design comes. If I have a very risky operation, maybe I need to make a verification system. A classifier has to verify the results of the other classifier. However, if I really need more performance, maybe I can make an ensemble classifier. So the design is different based on what, not now I have the result, the classifier gave me very good performance, but it gave me very good performance at the threshold 0.5. But well, I have to play with the threshold and see where do I want to go and what is my target. And based on this, I can plug my pieces for the better machine learning design. Now, in Morgan Stanley and in many other firms, I believe, we have something called model risk management. The model risk management is another department that has data scientists and machine learning specialists that review your design. And so you have to fill out a very hefty document. You have to explain all your decisions. You have to explain all your experiments, and you have to benchmark your work. So you say, I tried this using deep learning. I tried this using k-nearest neighbor, which is a very simple algorithm. I tried it using, and then you compare and you show why your decision is the best decision that we as a bank want to go with it. They also review if there is a reputational risk. Do you have the overlay for everything? Do you have all the controls around your model? Because it's not just putting a model. Sometimes you have to subsample your results when the machine is actioning. For example, the machine is improving. You need to subsample your results and look at this subsample. And before doing this in production, you have to see, when we do the subsampling, what is the best percentage of data that you have to subsample to see how the system is performing. Does it really reflect the whole population? So we really need to put a lot of control. We have to look at the feedback loop. Do I need to feedback or I don't need to feedback? How often do I have to train? How do I choose my data, even when I am evaluating? Does the time play an important role, or it doesn't play an important role? Can I have my testing data random from the training sample, or the testing have to be a period after the training? All these things we have to really look at them, and the model risk management, they will ask us about all these questions, why you are making this decision. Now, once everything is ready and you submitted your model risk management, because your POC is working, you know how you will put this model in production. At this time, the developer start developing your libraries and working on the system that usually data scientists, for example, work with Python, but our applications can be in Java. So you have to implement it in Java because it's real time. You don't need to bridge, because bridging will make it slower. Sometimes really you have to implement it in the same language as the language of your the original system. So the developer sits with the data scientist, understand what they did, and start implementing this. They work very closely with each other. They implement the features that you proposed, you worked on, and you make sure that, yes, it's generating the results that you want as a data scientist. And then the machine learning engineer sits and makes sure that the machine learning tools are connected properly. So that's the second part of this. And then at the end, we can put our system in production and see how it works. Even having the system in production, usually sometimes you can have it gradually in production. And usually the system cannot go live in production before being certified and approved by the model risk management. So it's not an easy process. It's a very long cycle just to get your model there. It's not just using these classifiers and passing the data and getting the output. You have to have controls and overlay over the output, and you have to make sure that you are passing the good input to the classifier. Now I want to go so quickly on how are the training and the testing processes working. There are some boxes missing. So this is an overview of how the training and the testing working. So when I do the training, I first look at the user's data sources. I pull the data from there. I apply the data engineering. Here it should be a data engineering to the data that I have. And after applying the data engineering, we do the feed our data to the classifier and do create this machine learning design and the model, and then we generate the model. This process can be really a very slow process. Like training can take half an hour, can take 1 hour, and it doesn't mind because it happens in the background. But the real-time process is the prediction. It is very similar to the training, so you have to engineer the data the same way you engineer them for the training. You have to apply the feature extraction, but here you don't have machine learning design, or you don't have the classifier to train. Here you train the classifier. Instead, you want to use the model that is generated by the classifier and predict. And then after that, you take your decision and make sure that every overlay, everything, all the controls are applied to the decision you have. I think I am really almost on time. I would like to go through, if you have any questions, I will go through your questions. And yeah, thank you very much. I'll just check if you have any questions. I did. Okay, I think there are no questions. Okay.